today I'll be showing you how to do a food calorimetry test. Okay? So this is a test to calculate the amount of calories, the amount of energy that's found in the food sample. Okay, so what do we need? We need a Bunsen burner, we need a boiling tube, thermometer, safety goggles, measuring cylinder, and this is called a mounting needle. This is simply to pierce the food sample that we're going to do. Okay, so what I'm going to do is I'm going to start by measuring a fixed amount of water, a fixed volume of water. In this case, I'm going to measure 20 cm cube of water. So I'll put my boiling tube neatly onto my report stand at about half the height. Okay, and make sure that it's try to make it straight. Let it look straight. Okay, next I will take my measuring cylinder and my distilled water. I'll squeeze out 20 cm cube of distilled water. Okay, remember to watch for the bottom of the meniscus. Put your measuring cylinder down. Look, prevent parallax errors. Okay, so I'll pour in 20 cm cube. And we should try to be accurate with the volume of water because that will affect our calculations. Okay, now I'll measure the initial temperature of water. Okay, so for me, I like to put my thermometer straight so I can see the reading easily. This thermometer does not want to cooperate. Okay, so I can see that the reading of the temperature right now is about 32 degrees. Okay, so I'll note that down here. Initial. So this is important because we need to find the difference in the temperature change, right? So later we'll take the final temperature and subtract away the initial temperature. Now, food. Right, so this here is a ball of Milo, right, and inside food is a chemical potential energy. So when we heat up food, the chemicals will combust. Okay, so I actually should have white towel for this. Never mind. I'm just going to pierce it, right, with my mounting needle. Just pierce it, so that the food remains at the top of the mounting needle. Okay, so I'll put it near to my Bunsen burner. I'll wear my safety goggles. Now for this test, we will use a luminous flame, which is orange, because we do not need it to be extremely hot. Take care that your surroundings are clear and put all the other things far away from the flame. And check that the air hole is closed. Okay, and then we are ready. Okay, so right now, we'll do one last check. Okay, so I will light the Bunsen burner with dark gas. Alright, and reduce the gas supply by a little bit. So this part, be careful because especially if it's windy, the flame might hurt you. So what you should do is to hold the end of your mounted needle, not all the way at the front, hold the end of the mounted needle and try like roasting a marshmallow. Do this for about 10 seconds until your food sample is fully on fire. Alright, once you see it's fully on fire, carefully bring it near to your boiling tube and wait for it to completely combust. Now this food sample will probably not completely combust. As you can see, there's some leftover chemicals here. Now quickly look at the temperature. We see that the temperature right now is 35. Okay, so the temperature is 35 degrees Celsius, which means, flame, which means the final temperature okay, so how do we find the change? Will be to take 35 minus 32 give us 3 Celsius, which indicates to us that the food sample has caused a change of about 3 degrees Celsius. Now we have used this formula called to calculate the energy in the food. Okay, so we will take the volume of water, which is 20. Okay, we multiply that by the change in temperature, which is 3 degrees, then we'll multiply this lastly by a number called 4.2. Okay, so this number is basically because 1 calorie is equal to 4.2 joules. It's just some physics, something that you just follow the formula. Okay, you'll divide this by the mass of the sample, which is 0.1 grams. Okay, so this food sample is 0.1 grams, so it's very light. Okay, now you'll get a number. Okay, I need my calculator, so sorry. I pause a while, I'm going to get my calculator. Okay, so I take my calculator, I type 20 times 3 times 4.2 and divide by 0.1. Okay, and I get the number to be 2520J. Okay, forgot to talk about something. Okay, so there's some reasons that this method is a bit inaccurate. It does not fully reflect the total amount of energy in the food sample. Right? So if you take any food sample, the size is not very consistent. So sometimes you might have a bit of a smaller piece. Some of them might be a bit larger, and so these are not equal, right? So the larger one probably has more energy inside, the smaller has less. Okay, so secondly, as you can see from the one that we did just now, this food sample did not completely combust, which means that there's still some carbon molecules left inside here, which does represent some chemical potential energy that did not completely combust, and therefore not all of the energy was calculated, or not all energy was turned into thermal energy, and therefore it's not a true reflection of the total amount of energy in the food molecule. Okay, so one way that we can actually improve on this experiment is to repeat the experiment 5 times, right, and find the average change in the temperature. Find the average change in the temperature for a few, and take the average. I repeat myself. Okay, yes. Thank you very much, and yeah, have a good one. Bye bye.